תודה רבה. Okay, so I am trained as a geophysicist, and I often find it extremely useful to start the discussion with a satellite image of that kind of reflects the issue at hand. This is a Landsat. Landsat is one of the NASA pieces of hardware in orbit, and it shows, of course, I don't need to tell anybody here, it's a Tukan. I don't need to tell anybody here, this is the Egypt-Israel border, and this is the GDPs, and there's a very significant disparity. About 42,000 US dollars per capita per year in here, and in less than an order of magnitude in Egypt. And lo and behold, you can see the border very, very readily. Okay? That is really important to keep in mind. I'm only really interested in those things that, those impacts of food that have a geophysical consequence. And clearly, this reflects maybe 90% or 92% of the incoming solar radiation. This reflects significantly less, order 70 or so. Okay? So you can very well say that the fact that in Israel grazing is not really a big deal, whereas here it's a matter of life or death, has an impact. You know, here we get about 1,000 on average, 1,000 watts per meter squared coming from the sun to the surface. Well, if you reflect upward of 90% or somewhere around 70, you make a very significant difference. So you can say that the choice that Israel made to have, or the economic trajectory that Israel is on is perhaps a better way to put it, has a readily measurable radiative impact. Okay, that's particularly useful to keep in mind after the last talk, because you know when you bring beef to Israel from, let's say, Latin America, okay, you bring it from an area which is almost equally as arid as the U.S. as Israel. But which has other very significant issues that kind of make the comparison not really very clearly justifiable. In Israel, water is a huge deal, as it is elsewhere. Land, for example, which in Israel one can argue is perhaps even more limiting factor than water, well, there's really infinite amount of it in Latin America. Of course, it's not really true, but it's close to that. Okay. From the standpoint of greenhouse gas emissions, it's often actually singled out as perhaps the Uber metric of both production in general and food production in particular. I actually take issue with that. I think that it depends on the location, and in Israel I would argue, since it's such a small country with greenhouse gas emissions that are trivial in absolute sense, it may not be the key issue. Water or land may far usurp that in import. But that's a matter, it's a subjective matter. Okay, as it stands in the U.S., if this pie is the total greenhouse gas emissions, you see that agriculture per se is only something less than 10%. It's not that big, but it's important to remember that no one of the sectors truly dominate this. It's very important to remember. If we had one sector that truly dominated, then it would have been the obvious thing to do. If you want to mitigate emissions, you go to that sector. Well, that convenience, unfortunately, is just not available to us. And that's true in the US, it's true in the globe, it's true in Israel. It's just a fact of life. Now, one thing I wanted to tell you here, so this is my estimate of how much greenhouse gas emissions it actually takes to feed the U.S. Okay? And the U.S., unlike what we heard in the last talk, the U.S. more than feeds itself. The U.S. actually feeds a large portion of the world. Okay? So this is how much it takes, something on the order of 1/5 or so of the national greenhouse gas emissions have to do with feeding the nations. So this is proportional. This height and this height are proportional. And you see the two non-CO2 greenhouse gases related to that, methane and nitrous oxide, related to, this is pretty much exclusively enteric fermentation, and then manure management is mostly that, although there's slight overlap here. Here's an important thing to remember that I think you probably have not yet gotten wind of, okay? In the geophysical community, in particular in the radiation transfer community, there is now a wholesale reassessment of the importance of non-CO2 greenhouse gases. And those neat factors that the AR4 of the IPCC tells us to use, 23 for methane and 298 for nitrous oxide, you can think about them as most likely obsolete at this point. I have a collaboration right now with a radiation transfer guy at the University of Chicago, Ray Pierre Humbert, and what we do is follow the path of beef production, but in light of the new understanding of the role of these two non-CO2 greenhouse gases in overall radiative transfer, radiative forcing. Yes, sir?
What's the scale, the magnitude of the difference that you're talking about? If you compare now the
you know what? It's a really good question, and I almost want to say this. The take-home message is that if you're going to weigh comparatively emissions of CO2 or emissions of methane, the latter is almost emit at will. Don't worry about it. Okay? It's not really true. I'm being facetious here. But it is alarmingly close to that. Okay?
You mean methane compared with CO2?
Exactly.
It's almost equal.
It's not that it's almost equal, but what I'm trying to say, perhaps poorly, is that emitting methane is something that you really need to worry about only after you worry about most other things. Does that make sense now? That's it. And that's really a novelty. It's just kind of...
so the whole issue with the frozen tundras in Siberia is a non-issue?
No. That's an enormous issue. No, this is... I don't want to... I do not want that to be the impression. The amount of and it's not just the tundra, but you know, continental shelves have enormous deposits of methane in the form of clathrate. I don't know if people are familiar with that. It's a piece of water ice with a piece of methane stuck in the middle, and it's sort of a spherical shape of the water ice molecule. There is an enormous amount of methane in those forms, and it is constantly being released. Those are very important environmental issues. I'm only talking about human impact, direct emissions of methane into the atmosphere. Okay? In terms of water, okay, I just plotted here, well, I borrowed really from here, the percent of agriculture in total withdrawals. Okay? And the picture that you see, I mean, of course, in Israel, you know, you can take a shower till kingdom come, it doesn't matter, really. It's agricultural uses that matter only. Okay? So, and really, when you want to ask in Israel, what is the correct price of water? The only correct answer to that, in my view, is the exact price it takes to desalinate Mediterranean water. Anything less than that is discounting water, perhaps with important and generally negative consequences. In general, what you see is that the low latitudes, people kind of tend to think of the tropics as being very hot and humid. That's true of a very small segment of the tropics. meteorologically speaking, most of the tropics are actually very arid. Okay? So if you think about a single landscape that in your head will characterize the tropics, what you want to think about is somewhere, for the Israelis here, a landscape like near Bet Govrin, or Drom Mizrach Har Hebron. Those are the places that are semi-arid. That's what the tropics are really like. Okay? And you see that the dark reddish colors tend to be in the tropical belt. Okay? So an important thing to look at Shira's results through is the fact that when Israel buys beef, Shira said just Latin America, but really it's that. It's those two areas, Nordeste, right here, and a little beyond that. The Nordeste is almost, like I said earlier, is almost as water stressed as Israel, and, but has unlimited land to speak of. Okay, so you need to think about the trade-off, okay, of bringing it from the European Union versus bringing it from somewhere else. The European Union has no spare land to speak of, but has a lot of water. Here, there's no shortage of land, but there's a whole lot of water limitations. Those are important considerations. It brings to the fore the question is, how do you optimize your choices? Okay, meatless Monday, fine. Oh, meatless whatever, right? But the question is this: what are you trying to achieve exactly? Mitigating emissions, reducing water consumption, reducing land consumption. Each one would lead you to different conclusions. Okay? In the U.S., land use, I would argue, and I'm not enjoying too much company in that, but I think it's a hugely important issue. How the land is used, okay? So you see that of the two large, this by the way, in terms of, this is in absolute values, okay? No, excuse me, this is not in absolute, it's all relative, okay? So for example, rangeland, which is where, you know, like, where cows graze, essentially, mostly west of longitude 100 west, it's about 21% of the entire U.S. Okay, this is I think it says it here somewhere that this percentage is of the whole U.S., including Hawaii and Alaska, most of which is not really suitable for production. Okay. Cropland is also around 1/5 or so, and as I'll show you later, a lot of it is supporting not direct human consumption, but human consumption piped through a very inefficient conduit, which is animals. Okay, corn alone is 4% of the entire U.S., and corn, contrary to popular belief, corn is not actually only used for animals, about 60% is, but 40% is consumed directly by people, but mostly or almost exclusively in forms that sicken them. You know, like high fructose corn syrup, etc. Okay? There's hardly any corn, you know, like corn on the cob, kelach tiras, there's no such thing, really, to speak of.
What is the percent that goes for ethanol?
Ethanol is not that large now. It enjoyed its peak sometime around 2010 or so, or 2009, something like that, and has been declining. But it never really dominated the corn scene. It was
part of it, but it didn't dominate it.
No, it did not dominate. It didn't come close, really. Okay. So that's that, and the total for food production is 47%. And check this out. This is the entire New England. I mean, I know that for Israelis it may not mean so much, but this is all the states that really most people from Israel come to visit. You know, New York, New Jersey, Vermont, Connecticut, New Hampshire, Rhode Island, all of those places. They are less than 2% of the union. Okay? This, just hay alone, hay is chatzir, hay alone is almost 3%. Okay? So when you look at it and you say, well, I mean, here was a country, right? And half of it went to animals. There was no discussion about this. There was no sort of methodical discussion that said, well, you know, we just need a tiny bit. For example, all of the fruit and nuts, etc., is just 0.2% of that. And we will settle for that, and cows will have the rest. No, there wasn't such a thing. And if there were, it could have been concluded by very different conclusions. Okay? Another thing that I think is extremely important, both in Israel and the US, is that of the key reasons species are lost, okay, and biodiversity is compromised, number 1 and 3 are related to, mostly actually to beef production. Okay? So agricultural development, well, I mean, most of the land that was wild before and now is not, goes to corn, wheat, etc., of which animals get a large share. Okay? And then grazing, which is exclusively beef. Okay? And that's 70% of all directly attributable cases of r'iyah. Okay? So over 70% of all the species losses that are directly attributed to a single cause are related to food production. And most of that, 70%, is related to grazing. I just spent some time with my family in Eilon, and we hiked down the Nahal Betzet. You can't go there without working your way through cows. You know, this is how it was. And Ron told me the same thing about Nahal Amud just a few weeks ago. And this is an example whereby what will be perfectly fit use of land in Wyoming or Montana, where you need to drive 200 kilometers between any two neighboring people, and Israel, where everybody is one on top of the other. Okay? One thing that I wrote several papers on is related to this, and I alluded to that earlier with the satellite picture. When you take any pristine landscape and replace it with agricultural production, okay, you really change the radiative properties of that landscape. And these examples are taken from the US, but they reasonably well apply to Israel. Okay, forest reflects about 10%. This forest is like near my house in New York State. It's you know, nice deciduous forest. And this prairie, where much of the wheat production of the U.S. occurs, is about 6%. Okay, so you have something on the order of 10%. Now you compare that to crops, and you see something that is 2.5-fold higher. Okay, so in a very real sense, you can say this, and if this is a calculation that was actually done. If it weren't for food production, the U.S. annual average temperature would have been about 1 degree Kelvin higher than it actually is. Higher. In other words, food production cools and negates anthropogenic greenhouse gas induced climate change. Okay? And that's about 1/2 split between the direct radiative effect, and the other is due to added evaporation and latent heat flux. Does that make sense to you? So you take a natural surface, you reallocate it to food production, you change the radiative properties of that surface, it reflects that much more incoming solar radiation, which means that it holds on to less, which means it is a cooling agent.
What's different about the plants or the way in which they're arranged for food production that leads to the difference in radiation?
That's a really good question. There are several things. So one of them is there's some a very important geophysical parameter characterizing vegetation, which is called LAI, for leaf area index. And that has to do with this. Picture, for example, a big tree. Okay? A photon coming from the sun might encounter the top leaf. Maybe if it managed to pass that somehow, just avoid it, it has another chance to be absorbed, and another, and another, and another. So the LAI basically measures the degree of overlap. So for example, an LAI of 2.5 means that there is presented to the heavens, there is 2.5 times more surface area of leaves per unit footprint than the actual footprint.
Since the trees actually absorb the photons, does this actually reflect changes in the temperature? So is the temperature much cooler in a field in respect to a forest, for instance?
Yeah, that's another good question, and the answer is no. The reason this is so much such an effective cooling agent is the fact that, think about it, how long, what fraction of the year does a field look like this? A very minuscule fraction. What's the rest? Empty field with either bare soil or, in the US, a pile of snow. That's the, those are the, yes sir?
Even though you're not re-emitting as much energy, why is that energy going to heat and not to, I don't know, photosynthesis or anything?
Yeah, photosynthesis you can talk to Owen about, but it's unfortunately not a very efficient process. A photon for photon, I mean, the energy, Owen, what would you say that is? Like a fraction of a percent?
Agriculture, it would be on the average of 1% in productive
1%.
agriculture. It's very unintuitive, but that's how it is.
Okay, so my point in trying to, in what I'm doing here, is trying to kind of give you a broader view. It's not just kind of accounting, I took some from here and I put it there, etc., that we often do, but the more fundamental geophysical impact. This is a calculation, it's a little difficult to follow, but let me try to walk you through this. This is from an 2009 paper where we just asked, consider a solar flux coming in of 600 watts per meter squared is the currency of global warming. If you talk global warming, you talk watts per meter squared. Okay? A typical light bulb, an incandescent light bulb, will be 100 watts. Okay? Every person roughly emits 100 watts, 100 joules every second. Okay? So this is a typical thing. Earlier today, the sun shone on Rehovot, maybe 1100 watts per meter squared. Okay? So 1100 joules came in every second from the sky into a unit square meter. Okay? This is a very pedestrian value, 600 watts per meter squared, accounting for winter, summer, day, night, all of that. Okay? And we asked this. So these lines differ in the albedo. Albedo is reflectivity, that's all. Albedo of albedo of 20 means of 100 photons coming in, 20 are lost back to space. Okay, does that make sense? Okay, so this is a natural albedo of 12, 3, and 8. Remember, this can be readily compared to these values. Okay, that a forest holds on to 90%, and the crops only hold on to about 75%. Okay, so against this backdrop, okay, if you take something like a forest, okay, and you replace that with crop with albedo, let's say of 22%, which is the characteristic for all crops, okay. The radiative forcing of that on the surface, you read it by going up vertically from 22 until you intersect the slanted line, and then here, and you get something, let's say, 50, 60 watts per meter squared. Just to give you a yardstick for that, all of anthropogenic greenhouse gas forcing up to this point from the beginning of the Industrial Revolution, under 2 watts per meter squared. With the water vapor feedback, I don't know if that speaks to anybody, but basically there are internal atmospheric processes that amplify what we put in the atmosphere. With that, it's less than 5 watts per meter squared. So here we're talking about something that is enormously larger, even though you have to remember, it only operates in specific times and places. Okay? So the upshot of that, in case you didn't follow every bit, is that when you choose to do the conversion that this slide shows pictorially, converting this or this to that, you are actually exerting a radiative forcing that is far, far, far in excess of anything that we managed to do up to this point with our Industrial Revolution.
And what's the average of Vito for crops across the year?
Yeah, that is an average, and you know, mature corn can be something like 35. Okay, corn is very, very good at holding on to the energy, and then you know it varies. I think I have here something anticipating that. No, I guess I don't. Okay, so are you satisfied with this? Okay, so let's skip the general introduction to biogeochemical cycles. Let me just highlight one additional impact of food production, and that is, in general, the Earth got its chemical composition within about the first 100 million years of its existence or so. The Earth accreted from the solar nebula, and when it was very, very young, it underwent differentiation, producing the core and enriching the crust with very light elements. And ever since then, all of those elements, mostly volatile and light, cycle between various pools. For the best known example is the carbon cycle. So the carbon cycle leaves are produced, they take up CO2 from the atmosphere, organic matter is formed, then it falls down, decays, it returns to the atmosphere as inorganic CO2. Okay? We took a key cycle of this exchange between the solid Earth and the gaseous Earth, and we basically called it our own. That is shown right here. This is the amount of nitrogen in the atmosphere that is being converted into a biologically active form. Okay? This is, as it tells you here, is in 10, tera is 10 to the 12th, right? I think so. Yeah, this is in 10 to the 12th grams per year, or I think it's 1 million metric ton per year, okay? And the natural biological nitrogen fixation, that's the name of the process of converting inert atmospheric nitrogen into a biologically available one, is in the order of 100 in those units. And then lightnings add a little bit more, okay? This is how much people have contributed on top of that as a function of time, and you see that the bulk is either growing legumes like soy or alfalfa and all of those, okay, and then fertilizer production. Okay, that is also extremely important when you think about it. You see it in this map of where is it. This is the percent share of specific states in the US in the total. And you see this is the Corn Belt. There's a very clear association between who is it that is growing corn and who is it that contributes to taking a whole lot of nitrogen from the atmosphere and turning it into essentially an environmental problem. Okay? Let me skip this. Okay? And now I want to show you an interesting calculation. Okay, this is on the way there. Let me just show you this. This is from an earlier paper. Okay, we basically compared in this paper two individuals eating the same number of calories, 3,800 kilocalories per person per day, but one of them is vegan and the other is eats like the mean American does. Okay. And what we calculated is that the difference between those two people subsisting on the same number of calories is that. And that difference, as you see right here, is 1.5 tons, metric ton and a half per person per day, per year. Okay? And just to give you a yardstick, in Israel, a person emits or is responsible for the emissions of about 12 or 14 tons per year. Okay? In the US, the number fluctuates between 21 and 25. Okay? Australia towers over everybody with 28. Okay? Against that backdrop, 1.5 is related to that difference. Okay? Between being plant eater or eating most of your calories from plants, but then also adding about 1,100 kilocalories per day from non-plant sources. Okay? This is non-trivial. It's not enormous, but it's non-trivial. Okay? Yes?
The results from your later study, 2009, are somehow included in this 2006 study?
No,
So it's actually even worse.
Tell me what you mean.
That there is the albedo effect, and which is not taken into account in your 2006 study.
Exactly. Those are two different papers, two different geophysical impacts, and they speak to each other in the sense that ultimately what we do is the sum of those, but they break the problem down into two distinct pieces.
How much of the crop in the States is for direct consumption?
Which crop? You have to tell me which crop you mean. All of the crops?
All of them.
Nearly all of it is, with the exception of corn, okay, and wheat. Wheat is about half and half, because pasta, bread, big deal, right? Okay, I'm sorry. I didn't answer.
Because when you're comparing a vegan diet and a non-vegan diet, you have to take into account that the meat that is reduced from my menu is going to be replaced by non-meat produce.
Exactly.
So, and that's why I'm asking if your 2009 data are somehow taken into account in your 2006 study.
No.
About the conversion.
Let me just say this. This compares two individuals, both of whom eat or consume 3,800 kilocalories per day. So the transformation that you're talking about is already folded in.
But it's the same
just to
amount
follow
of
up.
protein, for example?
No, I will get to that momentarily.
Actually, I know there's a lot of more interesting stuff on the way, so maybe you follow up on that specific point
All right.
later in the...
Okay, so let's, okay, blah, 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 blah. Another thing that is very big in the US, and here has really no relevance, is this dogged promotion of local. Okay? So local should be very you should be very careful about it. This is from a paper that actually I failed to publish up to this point. Okay, with this woman who worked with me, and what we're showing here, we're comparing two types of tomato production. Okay, one of them is organic, small scale. People love each other on this farm, and the other one is conventional, just Mexican laborers and all of that. Okay, so what we showed, okay, is that this is this perfect farm. Okay, I'm obviously using perfect in quotes. Okay. So this is the efficiency ratio, which is defined only for the purpose of this paper as edible kilocalorie output per fossil fuel kilocalorie input. Okay? So for example, 2 means you put in 100 kilocalories, you get 50 edible tomato calories out of it. Make sense? Okay? So these are various food items. Oats, by the way, the only food item that is better than oats, garlic. That is the only one that comes close, okay? Actually, and even is better. But garlic, how much you can eat of, okay? So the rest of it, you know, you can certainly eat a whole lot of oats. I do, okay? So there you get about 5 calories for each one from fossil fuel you put in, okay? This is what you get from those tomatoes, those perfect tomatoes. You get something well below 1, okay? So, in other words, if you ask yourself, okay, am I going to get 100 kilocalories from tomato raised in this idyllic environment, or from an orange just from randomly chosen farm? Well, this is the answer. So if energy efficiency is your thing, well, you will obviously, without a doubt, favor the orange.
How does this plot change if you internalize environmental impact?
It will change completely, and it will put these guys out of business. That's what it will do.
In what sense?
In the sense that if you need to pay to put CO2 in the atmosphere, they can't compete. They put for unit output that much more. And there will be some guy down the road who is capable of doing it for much less. So he wins. Okay, let's skip that. Okay, now I want to show you this. There are 4,000 dots here. Okay, each one, think of each dot as a person eating a fixed amount of calories as the average American per year. Okay, and I'm asking this. That person, how many acres does it take to sustain them? And how many pounds of reactive nitrogen does it take? Okay, that makes sense? So if you are a dot here, you need something like 20, your demand requires about 20 pounds of reactive nitrogen. If you're somewhere around here, it requires about 3 times as much. Okay? And what's the difference? Forget the difference between black and gray. Okay? That's a mathematical complexity that's not interesting. It's whether or not the minimization, formal minimization occurs. Okay? But this is these are 2,000 people eating like the mean American. In other words, 3,800 kilocalories per day, with about 1,100 from various animal sources, the rest from plants. Okay? These are vegans. Okay? They're only eating plants. And there is nothing in this calculation to force those clouds to be non-overlapping. Absolutely nothing. The calculation is blind to any I don't know, value judgment. Okay? It simply compares those guys. And now, to your question, these diets are, in a very rudimentary way, forced to be nutritionally acceptable. Okay, I'm no nutritionist, okay, and so I use a very rudimentary approach to this. It has to have the right amount, or within a range, within a tolerance range, the right amount of fat, specifically that which comes from animal sources, and calories, like I said, and protein. Okay? Those are the considerations. So, in the very basic way nutritional science is introduced into this calculation, you can say this dot or that dot or this dot are comparable, nutritionally speaking, with that. At least in terms of having enough fat, or not too much fat and protein, etc. Okay? the point is, just one second, the point is that when you are a plant eater, you are in that efficient corner. You use very little reactive nitrogen, and you use very little land. When you add just a third or so of your calories from animal sources, you shoot way up diagonally into a firmament that is just completely non-overlapping. And like I emphasized earlier, it need not be non-overlapping. This is not built into the calculation. This is spontaneously emerging from the calculation. Yeah, sorry.
So there are clouds of points. Why are they clouds? Like, what's the variation come from in the?
Well, I mean, you might choose eggplant today and chicken, and I may have today chickpeas and onion.
So there's some degree of randomization or something in these fictitious
Yes,
diets?
there is a whole lot. This is a Monte Carlo calculation.
Okay.
It is all randomization, but subject to those inequality constraints. Am I speaking your language?
Yes.
It sounds like it. Good. Okay. So, all right. Let's not worry about this. And now, as a crescendo here, we're getting to. I know I may be overstepping my welcome, so I'm going to quit soon. But let me just show you those results that are very fresh. That Ron from here, Ron Milo and Alon, and one other woman, Tamar Makov, and myself got recently. Okay, so what we to start with, okay, this is the same measure that I introduced earlier with the tomatoes. Okay, feed calories in the tomatoes it was fossil fuel, but it's the same idea. Okay, feed calories in. Versus the human destined calories you get out of that. Okay, the 10-to-1 ratio is shown here as a yardstick simply because anybody who took a casual class in ecology, they talk about that as the cascade of energy within trophic levels. Okay, so what we have here, there are no plants in this one. There are only the 5 categories of animal sources: dairy, eggs, poultry, pork, and beef. Right? And you see that some of the categories, like dairy or eggs, fall. I mean, there's nothing magical about this value. It's just that we all learned about it in undergraduate, so it's worth putting here. The point is, these are more or less comparable. They're arranged in descending order, so they do descend. But they're more or less comparable within the uncertainty that is given by those uncertainty bars. And then, by contrast, you have beef, which is truly unique in the amount of feed calories it requires in order to produce a fixed amount of human destined calories.
Gidi, if I may one tiny comment?
Yeah, sure.
In this plot, being high is bad. You remember previously being high was good.
Thank you. Good point. Yeah, Ron is nothing if not extremely smart. Okay? So that is true. And now there is one thing here which is worth breaking down, and that is, you might say, well, all right, but beef really is free, isn't it? I mean, it grows in Wyoming where nobody anyways wants to live. Okay, I do actually, but that's a separate story. So let's talk about it as though it is a free resource. Okay, I think the most strong argument against that would be the biodiversity argument I showed you earlier. But let's just go with it. Okay? So what we see is that even if you discount completely pasture land and the inputs, in particular in this graph, the inputs that go into maintaining pasture land, it is still like nothing of the other categories. The upshot of this is, if you're worried by which you're trying to optimize your diet is energy efficiency, eat those to your heart's content and avoid this whenever possible. Okay, right. And this is the analog of that. Instead of in the denominator, instead of 1,000 kilocalories of edible product, you have a gram of protein. Okay, so that is in deference to our friends from the nutritional science who tell us, well, not all calories are the same. You have this calorie and that calorie. Fine. This takes note of that. Okay, the picture doesn't really change, right? That's what this shows. Okay, and now
Maybe you could show just the plants and the gray on the bottom.
yeah, that's a good point, Alon. Toda raba. This range right here is spanned by a few plants that we chose because, well, one thing they are representative of what people eat, and the other is we were able to get data for it. Hello, it's not that easy to get that data. Okay, so that's the point. You see that none of them comes anywhere, or not anywhere, but I mean they're all above it. And remember what Ron said: up is bad, down is good. Okay, here in this graph. But really, dairy or eggs, it's not so bad. So if you like yogurt or you like scrambled eggs, just have them, basically, if this is your consideration.
I'll leave the question for later.
Okay. So now we're using, this one is unique, okay, so we'll address it momentarily. These four are kind of interchangeable. This one uses land demand as the environmental metric. This one, the amount of irrigated water consumed. This is the greenhouse gases emitted, and this is reactive nitrogen consumed. Okay? Remember this, I didn't really say that, but why do we care about reactive nitrogen? Water quality compromising. Okay? So, and all the rest I think is pretty obvious, right? You have finite land, you have finite water, blah, blah, blah. Okay? So, in all of those, in all of the panels, these are the different categories right there. The eggs, pork, etc. Okay, and the units vary from panel to panel. For example, with land, it is meters squared times year needed in order to produce a megacalorie. So, for example, the value of 10 here means if you want to produce a megacalorie of, let's say, pork, okay, or whatever, okay, a value of 10 means if you want to produce a megacalorie from that source, you better be willing to allocate 10 meters squared per whole year. Okay, makes sense? So the point here is, again, that these guys are more or less comparable, mutually comparable, all right? And the beef is truly in a firmament entirely by its own, unparalleled by any of the other ones. Okay, so here again, the corollary I introduced earlier, if you like your animals, fine, have them, just be sure that they're not beef. Okay? Or whenever possible. And that is reproducible across the different metrics. Okay? Yeah?
So there's this common argument in the States that like the reason that beef is so bad is that we raise it in an unnatural fashion. You know, we force it to eat all these things it doesn't eat naturally as a ruminant. What is it? How much would this picture change if all of the beef was pastured? Is it possible to pasture all the beef that we grow in the United States, like for its entire life cycle, as opposed to pasturing and then finishing the way it's done now?
Your question is good, and it has one part that's really easy to answer, and the other is impossible to answer. Okay, let me get to this. If you compare two beef production systems, one based on grass, the other based on trough mixture, the grass-fed beef emits about 220% the methane. Okay, now to that we must add what I said earlier, which is the role of methane in radiative forcing is now vigorously reevaluated. Okay, in addition to that, however, you have, and here's the part, so that was easy, right? The part that's not easy and truly impossible at this point is this. If you raise beef like they do mostly in this country, in Israel, which is feeding them at a trough, and mostly grains, okay, then they eat very low content of complex carbohydrates and very high content of simple sugars. Okay? They're not meant for that. Rumination, evolutionarily speaking, is about the ability to break down cellulose. Okay? We don't take advantage of that, so they emit much less in terms of enteric fermentation, and we instead invest that much more in fossil fuel energy to produce fertilizer. Okay?
And some antibiotics maybe, no? Has to do with this?
Yes, but antibiotics is, again, it's a value judgment mostly, and it's a human medicine issue. It's not so much an issue of greenhouse gas emissions.
Yeah.
Okay? So you do that, and then you do this trade-off, and it's up to you. I mean, do you have unlimited land, for example? Graze them, okay? And graze them very infrequently so that they always get the fine stuff. You know, grazing, like think about up in the Golan, okay? Grazing in March and grazing in July are completely different things. They have almost nothing in common, okay, in terms of the ratio of simple to complex carbohydrates, simply because the season has progressed. Okay, so the upshot of the answer is it represents a trade-off. That trade-off needs to be addressed individually depending on the resource limitations that you face and your choices. Okay?
If you're looking at biodiversity, so
Yes.
the grazing is much worse.
Absolutely,
Yeah.
much worse. Yes, yes. And to that, there's a counter-argument as well. Even though I said absolutely yes, there are others, perfectly sensible people, who advance a counter-argument to that, and that is that there are some papers, not very persuasive in my view, but there are papers that show that carefully managed grassland is in fact somewhat amenable to biodiversity. Not like the natural biome it replaced, but somewhat. Better than a sterile field of corn, excuse me. Okay? So that is that, and basically you go throughout the different metrics, and that's where you get. This, however, is what Americans actually eat, irrespective of efficiency, and you see that dairy is the biggest caloric contributor, okay? And it doesn't stand out as being particularly inefficient or efficient. It's just somewhere in the middle. And beef is second, and beef certainly does stand out as being the single most inefficient there is. By contrast, eggs, which are relatively very efficient, contribute very little. And again, you want to say, well, I mean, maybe eggs have a lot of cholesterol, and if we subscribe to the cholesterol dogma of human nutrition, you don't want that. But that's a separate story. Okay, I'm going to truly wrap it up now. Okay, let me just say this. This is a huge favorite of mine. Okay, this just asks, suppose, this kind of goes to that question, suppose you want to produce the current U.S. beef consumption using only grazing, okay? So this is the land that you will need, okay? And this is the amount of land that you will need for that. This is the amount of land that you will need if you are going to feed them with, put them in a feedlot and feed them. And this is what more or less the U.S. currently does, which is a mixture. Okay, but you see the difference. I mean, it's 20 up there, upward of 20, and it's something like 2. So it's an order of magnitude. Just as
how much is there total?
What?
How much pasture land is there in the States
Oh,
total?
this is a manifest impossibility.
Okay.
Yeah. Yeah. I'll be happy to go back to that if people want that, but I just want to wrap this up now. Okay? So I hope I convinced you that, and probably I didn't have to, but anyways I did it. Dietary choices and agricultural policies really, really matter. Okay? And they can have a zeroth order impact on what's going on. Okay? Plants often, but not always, outperform animals in efficiency. You want an exception? Spinach. Spinach is not particularly efficient. Okay? That's what this says. Beef is the one to avoid whenever possible. Okay? Grass-fed beef is a non-starter. We can talk about it till kingdom come. It really is an impossibility. Okay? You can do a little bit, and that is worth discussing, but you cannot go to a full grass production system. And finally, this is perhaps a bit overly polemic, but it is, I think, basically true, and that is that some serious environmental problems are a choice, really, and they are optional. You want to eliminate them, eat accordingly. You like them, eat the way you do now. That's essentially the upshot. Okay, thank you very much. I'm sorry I...